Hello everyone, welcome to the solving stream. We're solving Advent of Code Day 2 today in Python. Hopefully you can hear me. Please say something in the chat if you can hear me, because yesterday I managed to start the stream and I was going on for 2 minutes before realizing the sound was not on, which was a bit embarrassing, but also just how these things go. So hopefully today you can hear me from the beginning. I double checked the mic, so the problem today will be something else. Like I said, we're going to solve day 2 of Advent of Code. I did solve the problems beforehand, so this is not going to be a... You're not going to see my first reaction to the problem or my first thoughts, because the point is for this to be more pedagogical in the sense of how the solution looks like and not necessarily the process of getting there. Although I will try to give you some insight into that as well. So I guess without further ado, let's get started. If at any point you have any questions, any comments, any remarks, feel free to say something in the chat. I'll be taking a look at the chat to make sure that everyone understands everything. Alright, let's open VS Code. So you can see I even have a couple of solutions already that I wrote earlier. And now let's make sure that you can read this by making it larger. And we're going to create a new file for our solution. So what does the problem say? Wrong tab. What does the problem say? I'm not going to read the problem statement. I'm just going to give you the gist of it. Your input looks like a long line with ranges that are written out like this, comma-separated ranges. A range is given by a left and a right endpoint, separated by a hyphen. And what you need to do for part 1 is to find what they call invalid IDs. And an ID is invalid if the string representation of the number is made up of two halves that are the same. So for example, Olá, Angie. Sorry, Olá is Portuguese. Yeah, today was a fun day. As the days go by, you're supposed to have a harder time, but that's not always linear. So today was slightly easier for me because I didn't get stuck in a silly bug like I did yesterday. So strings like or numbers like 11 or 22, they are invalid IDs because 11 is made up of a 1 and a 1. Let's see another example. The ID 222 that's contained within this range, right in the middle, that's going to be an invalid ID because it's made up of the string 222 together with the string 222. So those are the invalid IDs for part 1. Alright, so how can you solve this? Well, but as soon as I read this problem, I felt the urge to go through all of the numbers in the ranges and check if they are invalid. And this is in line with what you would call a brute force solution, where you just check every possibility and you see if it's an invalid ID or not. But one thing I always like to try and do is try to figure out a more constructive solution. Instead of going through all of these ranges exhaustively and figuring out if the numbers are invalid, can I instead try to construct all of the invalid IDs directly and sum those? And that's what I did for my solution, and it's what we will do here. So the first thing I'll do is write a function to parse my input. I'm going to give it a file path. And I'll just open my file in read mode. And then what do? I need to read the whole file, which is just a single line. I'll trim it to make sure there's no extra white space at the end. And then I'll split on commas. And this should give me all of the ranges, or at least a list with all of the ranges. Now what I want to do is go through each range and split it along the hyphen so I get a pair with the starting point and the end point. So this gives me a number of ranges. What I can do is make this a list and use a list comprehension. So what I'll do, I'll take each range and split it on the hyphens for range in this sequence of ranges. And now I get pairs that have strings, and what I want is the integers in those strings. So what I can do is I can map the built-in int over that range and then turn this into a tuple to get my pairs. And now if I return the ranges, now if this is the main program I'm running, I'll run my main. I'm giving it just a little bit more structure than yesterday. And now here I'll parse my input.txt, and now we run this, uv run solution.py. Actually, let's print this parse and then we print the ranges. I don't know why I said trim. You want to strip. This is the string method. Alright, Anja says that the brute force solution works. Yeah, I saw lots of people doing the brute force solution and it worked in a decent amount of time. I just immediately thought, can I do something that's more constructive? But yeah, the brute force solution will work just fine for today, both part 1 and part 2. If I'm not mistaken, even with Python, like you say, which is not supposed to be particularly fast language. So these are our ranges. And then the next thing I thought was, if I'm trying to build numbers that are made up of two halves that are the same, I need to be able to have two halves. So this only works for numbers with an even number of digits. And some of these ranges some of these ranges have sub-ranges that have odd and that have numbers with an odd number of digits. Sorry, that's too many times the same word meaning different things. For example, this range over here starts with 5-digit numbers, and I know that up until 99,999 I will not have an invalid ID, because those numbers from 73,000 something up to 99,999, those all have 5 digits. So I can skip those. So the next thing I did was take this input and normalize all the ranges so that all ranges are within or have two endpoints with the same number of digits. So essentially what I want to do is I want to write a function normalize ranges that accepts some ranges, and so takes a list of ranges and builds another list of ranges where all ranges have endpoints with the same number of digits. Examples, like the range 10, 23, this stays the same because 10 and 23 have 2 digits, but something like 753 1010 gets split into 2 different ranges. That's going to be 753 999 and 1000 1010, just to make it easier for the rest of my code to work through the ranges. Because again, what I'm trying to do is be constructive about the IDs. If I was just checking if every single possible ID was invalid or not, I wouldn't need to split the ranges. But for my solution, I did this. So how do we do this? Well, the normalized ranges, I'll start off with an empty list. I'll go through each range, take the left and right endpoints of each range. And now, examining my input, I can see that the endpoints never have more than a digit of difference. So this is 3 digits and 4 digits. But what we can do here is handle initial ranges that might have a larger difference. So this function can actually do something like, if you take these two numbers, it's going to break this up into 3 separate ranges. So that's going to be 10,000 and then up to 1050, 10. So that's what the function does. For that, I'm going to go over all possible lengths, which start at the length of the left endpoint and end at the length of the right endpoint. Am I missing parentheses? No, I'm not. Now the left, so now I'm building the broken up ranges, right? What's the left endpoint of a broken up range? It's either going to be the original left endpoint or a 1 followed by a number of zeros. So the left of the subrange is either left, if I just started, if this is the first, or a 1 followed by a bunch of zeros. And the right endpoint of the sub-range, it's either going to be the original right endpoint if we are at the end. Otherwise, it's going to be a bunch of 9s. Now we take the normalized ranges, we append the sub-range we built, and when we're done, we return the normalized ranges. All right. Now let's take the original input. Notice how the second range here goes from 5 digits to 6. But if we normalize it, and if we run our code again, we get an error because these are integers, so I need to get the length after converting them to strings. Right, because the endpoints are integers and I was trying to get their length, but that doesn't make any sense. And so that means I'm going to have the same issue here. And now we run. And wait, what's going on? Oh, I see. And as you can see, the second range was broken up into 2 ranges. I just forgot to convert the strings to integers because I'm silly. Let's close this. So what's the issue? The issue is subleft might be a string in this case. So let's make it an integer. How did I move the t over there? Subleft. Yeah, so length doesn't work with the integers. That's why I had an issue here. Now, am I making sense so far? Do you folks understand? Does everyone understand more or less what I'm trying to do? Because if not, you have to let me know sooner rather than later, because the deeper I get into this, the harder it's going to become to follow. It's a nice comment in the chat saying that I can definitely compute the length or the number of digits of a number using the logarithm in base 10. Which, as a mathematician or as someone with a formal maths background, I maybe should prefer. But I don't know. For some reason, I went with the length of the string for this problem. Now, how many is this too long? It doesn't fit fully in the screen. Count characters. 90. Yeah, this is a pretty long line. Let's do left if else. Alrighty, now this should be normalized. Let's run our solution. So as you can see, the second range gets broken up, which is what we want. Now, what we need to do here is do this constructive thingy I keep talking about. So how do we do that? Well, if I look at a range like this one, let me copy this, let me open Excalidraw. Let me paste this here. When I look at this range, I immediately know that I only care about, or that I might only have invalid IDs here that start with 503 up until IDs that start with 597. Like, for example, I know that the ID 401 this ID does not fit inside this range. Why not? Because its first half is under the first half of the left-hand point, right? It's to the left, so I don't need that. So what I can do is, for each range, which is now normalized, I'll grab this part and this part, and what I'll do is now I'll build 503. I'll build 503, 503. I'll build 504, 504, 505, 505, all the way up to 597, 597, or rather 596, 596, and then 597, 597. And I will check whether they are inside the range or not. Well, I know that these ones will, all of these ones are. I just need to, the ones that I need to be careful of are actually the first and the last. But this allows me to just generate the invalid IDs, and I save a lot of time. Instead of going through roughly 100,000 numbers, this range contains roughly 100,000 numbers. Instead of going through them and checking one at a time if they're invalid, I just need to generate the 96 potential candidates. And 96 is much smaller than 100,000. I'm not sure if you agree, but I think this is something that's reasonable to say. Like 96 is much, much smaller. So that's what we'll do. Questions about the idea of splitting the number in half, or is it making sense? All right, so let's write a function that takes a number and produces that half for me. So I'll take a number with an even number of digits, return the integer of the first half. Sure. Now we take this, we convert the number into a string, and since s is even, what can I do? I can return the integer version of s slice up until the length of s divided by 2. So this is going to give me the first half. Let's test it. Let's do print half 503, 56, 576, for example. If I run this, if you run solution.py, I get 503, which is what I wanted from this number. By the way, a quick detour. If you're ever slightly lost about the way slicing works and what's included in the slice, I have this really good mnemonic that I think can help. Like, take a look at the string slicing here in the center. If you imagine vertical separators around the elements of your sequence, which are these vertical lines in between the letters, but also in the beginning and the end, and then if you number them from 0, so the first separator is 0, the second separator is 1, etc., then a slice, like s of 3:6, is going to give you the elements between the separators with the same indices. So a slice from 3 to 6 starts at 3, gives you the C, the I, and the N, and goes up to 6. I think this is a pretty cool mnemonic. I still use this. I've been using Python for 13 years. I still think about this visual representation of slicing to avoid making mistakes. Now let me know if this is if this feels like a useful mnemonic or if you do something else. Great. So we have the function to halve a number. Now let's write the function that solves part 1. Given some ranges. Sums all invalid IDs within the given ranges. I see some folks saying that this was a useful mnemonic. Well, I sent it today inspired by today's challenge. I send these to my drops newsletter. So if you want, feel free to subscribe. I send a short tip, a short Python drop each business day. Alrighty. Now that the shameless plug is out of the way, let's actually leave that there for a second. What do? The invalid ID sum, or invalid ID sum, starts off as 0. Now I need to go through each range, and I'm destructuring here. Ranges includes pairs, so this allows me to split the pair into the left and right endpoint. And now, what can I do? I can skip ranges that have an odd ranges with endpoints that have an odd length. So if the length of the string version of left, when divided by 2, leaves a remainder, then I want to skip this range. Otherwise, I'm going to grab, I'm going to grab the half of the left and the half of the right, and I'm going to create a range through those. So 503, 504, etc. up until 597. And then I duplicate it to create the full number. That's the idea. And I create a range through this. So I need the halves on the left and the right. In code, that's going to be the left half of the left, the right half, and now the range. So for each half in the range of HL and HR plus 1, because it's inclusive, the number is actually given by concatenating the half twice, an integer, and then if the number is inside the interval, then we add invalid ID sum plus equals the ID, and when we're done we return all of the invalid IDs. So this normalizes the ranges. Now we solve and we print. Let's run this, see what we get. 299 something something 4880. And if you look at my solution, because everyone gets a different input, my solution is 299 something something 4880. Alright, so this is correct. I'll give you a second to ask any questions you might have while I take a sip of water. Alrighty, let's proceed for part 2, or proceed to part 2. What does part 2 say? Brief overview of the challenge and their solution. Alright, so the challenge just is going to become slightly different now for part 2, but the challenge for part 2 says you're going to take a bunch of ranges like this. They're represented like this. And now what you need to do is, within these ranges, you need to find all of the invalid IDs that are within the given ranges. And then what you have to do is figure out how to represent or work with these invalid IDs. And the definition of what an invalid ID is depends on the part. We just did part 1. For part 2, an ID is invalid if the number as a string is made up of a repeated substring. And I have a bunch of examples here. For example, 11 and 22, they're both invalid because 11 is 1, 1 and 22 is 2, 2. 99 is invalid because it's 9, 9. And 111 is also invalid because it's 1, 1, 1. So it's a 1 repeated 3 times. And for part 2, this counts as invalid. Other examples include, let's see what's different here. For example, 56, 56, 56, this is invalid because it's 56 repeated 3 times. And this one, 1, 2, 3, 4, 5. And this big number, 21, 21, 21, 21, 21, repeated 5 times, that's also invalid. So what we need to do now, we already have our ranges normalized by the length of the numbers in terms of digits. Now we just have to generalize our code. We don't only care about the halves, we also care about smaller possible subpatterns. So now what I want to do is, let's see if I can delete or erase, nope. Okay, yes. Yes, all right. Before we were splitting the endpoints in the middle, but now because the patterns might be repeated more often, they might be smaller subpatterns repeated more often, what I'm going to do is I'm going to check patterns that have a single digit repeated 5 times. So in this case, I only need to check for 555, 555, which is the same digit repeated 6 times. Actually, let's match the colors here. Now, I will check for patterns that are 2 digits repeated, and for those I will need to check 50, 50, 50, 51, 51, 51, all the way down to 59, 59, 59, and then, just like we did for part 1, I'll check patterns with the repeated halves, which are what's written here. So this is my idea for part 2. Let's see. Alright, if you have questions, feel free to let me know. So it's a very similar solution. I just need to, instead of working with halves, I want to find all of the splits. So let's maybe move this here. So that was part 1. Let's do splits. So splits of n, this returns all prefixes of n as a string that have a length that evenly divides the number of digits of n. What does this mean? For example, if n has 6 digits, then I'll return the prefixes 1, 1, 2, and 1, 2, 3. But if n has 8 digits, I'm going to return the prefixes 1, 1, 2, and 1, 2, 3, 4. Because 2 and 4 divide 8, which is the length, but 1, 2, 3 would have length 3, which does not evenly divide 8. So that's what I'm doing. All right. How do we do this? What do you mean by odd numbers? Do you mean numbers with an odd amount of digits? If so, yes, because odd numbers can also be composite numbers. For 1, 2, 3, 4, 5, 6, 7, 8, 9, which has 9 digits, I would return the substrings or the prefixes 1 and 1, 2, 3. So now we go over the target length, which starts at 1 and goes all the way up to half of the length. So that's going to be, we still need the string version of n, the length of s divided by 2 plus 1, because it's inclusive. And then we check if the target length evenly divides the actual length. So let's do len of s, because I'll reuse this a bunch. All right, so if length divided by the target length leaves a remainder, I want to skip this target length. Otherwise, I have a valid prefix. And the prefix here is s up until the target length. Now we return the prefixes. Let's test this with this number. So let's print the splits of 1, 2, 3, 4, 5, 6, 7, 8, 9. And we run the solution. And we get this, the prefixes 1 and 1, 2, 3. And this should be an integer. We want to work with the integers because we're going to generate ranges from these. Well, this was the generalization of the half function from the first part. Before we just did halves, now we do all possible smaller splits. And now we can actually copy part 1, paste it, and a small adaptation will be enough. So we're pasting part 1, let's call it part 2. Sums all invalid IDs within the given ranges. Now an invalid, or rather an ID is invalid if it is made up of a sub-pattern. Of any length. So the invalid ID starts at 0. We're still going through the ranges. But now we don't want to check for odd lengths here, because odd lengths for part 2 still matter, so we get rid of this check. And now we don't want to halve. We want to get the smaller splits. So what we're going to do is the left split, we're going to grab the left and right splits from splitting, what's the function called? Splits, right. From splitting the left endpoint and the right endpoint. And what's going on here? I think like this line, this small piece is very, I don't want to say brilliant because I wrote it, so it's going to sound terrible, but if you think about it for a second, this is great because we normalize the ranges, left and right are guaranteed to have the same number of digits, right? The same number of digits. So I don't know how many splits left will have, but I know it will have exactly the same splits as right in terms of lengths and, well, the total number and the lengths of each split. So I can pair them up with zip and go through them like this. And this is the corresponding, or this is the same. Sorry, this is the generalization of getting the halves, the left and right halves, and then doing the range. Now you get the left and right splits, and now you do the range. So instead of halving, you do this. And now instead of doing the for half in something, you do a for sub-pattern in range, starting on the left split and going up until the right split plus 1, because it's inclusive. And now you don't want to build the number by putting the two halves together, because you don't necessarily have halves. What you do have is a sub-pattern that you want to repeat. So the number is going to be a multiplier times the sub-pattern. Now what's this multiplier? It's whatever number you need to make sure that this thing has as many digits as the original left endpoint. So the multiplier here is going to be, the multiplier is given by the length of the left divided into the length of the left split, the left split, for example. And I'm just doing the floor division. I know that this division is going to return a whole number, but I need this to be an integer. So I'm using the floor division here. This builds our number, and then if it's within the original range, then it's invalid. Now this, I might have convinced you that this is correct, but this actually doesn't work. Let me run the solution. This should give you, well, for some reason it started by giving me 0. So that's not what I expected. I expected it not to work in a slightly different way. Let's see if we can figure out what's wrong. And by the way, if you see what's wrong, just let me know. Put me out of my misery. If the number... of course. So the sub-pattern here is an integer because it came out of the range. But when I'm multiplying it here, I want to multiply the sub-pattern as a string to repeat the sub-pattern. So we're going to run the solution. And this is the number I get, 487 something something 459. 487, and as you can see, I'm slightly higher than what I should be. My answer is slightly above this. Now what's the problem? What's wrong in my solution? It's not necessarily obvious. Thankfully, when I was solving this the first time, I got there quickly enough, but this is the kind of thing that could have taken me ages to figure out. The problem is in numbers like, let me open Excalibur again, numbers like 12, 12, 12, 12. This is an invalid ID. Why? Because it's made up of 12 repeated 4 times, but it's also 1212 repeated 2 times. And in my code, I will generate this invalid ID twice. Once for the subpattern with length 2 and once for the subpattern with length 4. So I need to be careful not to sum the same invalid ID twice. How can you fix this? Thankfully, it's easy enough to fix. You just create a set with all of the invalid IDs instead of summing them directly. So you create a set, and in the end, you just sum whatever is inside the set. Because sets don't have duplicates, this will take care of ensuring I don't count the same ID twice. And if I run it now, I get the solution I should get, 486 something something 998. Let's double check. 486 something something 998. All right. Let's put the code up on the screen. This is the code for part 2. Let me know how you feel about this. Let me push this to GitHub. And I'll paste the link in the chat just in case you're interested. Just this here, and that should be slash. All right, the link is in the chat in case you want to take a look. Yep, that's what I did for part 2. And sets are amazing in case you didn't know. All right, so if you don't have any questions, I'm thinking, I mean, you can send questions at any time, but if there's no questions for now, I still have a couple of minutes. I have roughly 20 minutes. What if I'm thinking of going back to yesterday's problem, and yesterday during the stream I started a visualization for the problem that involved a circular dial going left and right. I'm just thinking of going back to it and working a bit more on that. How do you folks feel about that? Does that sound? I mean, if it doesn't sound interesting, you can just leave the stream. There's nothing I can do to keep you here. But would you be interested in taking a look at that? So let me know. Alright, my dear friend Angie is saying, yeah, go for it. Thank you for your motivation, let's do it. Okay, how do I go there? Let me move up. Let's open VS Code there. Let's take a quick look at what we had. UV run dial.py. So what you have is a terrible looking dial, circular dial. And what is it doing? Right. And it just rotates according to your puzzle input. It's okay, Angie, come on, you can live your life. Feel free to I appreciate you being here, but of course you can leave. I won't be upset. So this is the dial for yesterday. The problem was you get a bunch of numbers like these with right and left rotations. The dial has 100 positions, and you have to check how many times the dial stops at 0 for part 1 or crosses 0 for part 2. And where did the dial go? We already have something that rotates. As you can see, it's going over the input and doing random rotations. What I want to do now is add a visual cue to indicate where the 0 is, and something that tells us what turn we're processing and how many times it stopped at 0 and how many times it went over 0. So let me think for a second. Alright, let's start by adding the visual cue for the 0. This is Pygame code, because Pygame is the only visual library I know in Python. I know how to use. And I have a function that draws the dial. So now what I'll do is I'll draw a small tick at the position for the 0. So that should be a line. And drawing a line looks like this. So it takes the surface I'm drawing on, which is the screen. It takes the color. Let's make this purple. And now it takes the start and the end points of the line. I want the 0 indicator to be at the top. So that means this is not aligned, right? So center X is the width of the screen divided by 2. And the top of the circle is at the center Y plus the radius of the circle, or minus the radius, because the Y increases as you go down, so if you want to go up you have to subtract. So this is the radius of my dial, and this is the tick X and the tick Y, and then we'll do the tick slightly above and slightly below this position. So this, let me open the window again. What? Endpoint is not defined. Right, because this is not supposed to run. The coordinates I have there, that I computed there, tick X and tick Y. Gotta give it a second. Or is the window somewhere else? Oh, it is here. So the coordinates I just computed, they're in this position here, right at the top of the dial, and I want to draw the tick there. So what I'll do is, I'll draw the line I had, the purple. Now the starting position is tick X, tick Y minus, let's do, I don't know, minus 10. We'll see if it looks good. And the end position is plus 10. And for the width, let's do 4. See what this looks like. Let's run it from here. I think it's, where did this go? Where's my Pygame window? Okay. Oh, it's terrible. You cannot see it. It's there, but the contrast is terrible. That's why developers should learn some color theory. I don't know what color to put there to make it visible. I'm going to reuse black. I'm going to make this thicker. Now let's run the dial. There you go. Now it's more visible. Now there's a problem I know I have, because we had it yesterday and I haven't fixed it yet, which means it's still here. And that is, this is not really the 0. So when we think about the dial, or at least when I think about the dial, I imagine the 0 at the top. But right now, because we're using trigonometry to draw this line that moves around, the 0 is currently on the right, so we have to fix, I have to fix the drawing of the pointer to make sure that I consider the 0 to be at the top. So the function that draws the pointer takes the pointer position in a number from 0 to 99, so the number we're pointing at in the dial, and it figures out the angle so that we can use a little bit of trigonometry to compute the position where the pointer goes. And this is where I can fix the 0. Sorry, my dog is going mad. I'm not sure if my mic picked that up, but my dog was upset about something. So how do we fix this? Well, I need to think for a second. We need to do an offset. So move the 0 to the top of the dial. And so we want this 0 to be the 25. So the 25 plus moves, and this is the kind of thing you want to comment. You don't want to add a comment here saying you're using cosine and sine to compute the position, because that's what's written in the code. The sine and the cosine literally give you the position. You want to add something like, why are you adding 25 to this number here? Like, what's this thing doing? All right, so now did this fix it? To check, I'll just draw the pointer at position 0 and make sure it's at the top. So for that, I need to go to my code that does the animation, and I need to ignore all animations and just paint it at the top. So let's do draw pointer at 0. I'll ignore all of my animation code, and hopefully the pointer is at the top. If it's not, it's because I made a mistake. Dial.py. Where's my dial? I don't know why Pygame insists on creating it in the wrong place. Of course I got it wrong. It's pointing down, which is not what we wanted. It should be pointing up. How did I mess this up? How do angles work? Oh, of course, because... Okay, sure. It's because the Y is inverted, so this should fix it. UV run dial.py. Amazing. And I'll tell you what, when you go left, let me... Where's my input file? I'm going to add a... I'm going to save this elsewhere. I'm going to create a fake input file that just has a single rotation to the right. If I restore my animation code, so let me fix the comment because now I'm lying. So position minus 25. And now if I reset or restore the animation code, and note how I have a single rotation to the right, and yet if I run my code, the dial is rotating. Oh wait, it is rotating to the right. I thought this was flipped as well. Why is this correct? Well, I mean, I'm glad it is. All right. So now we have the tick. Let's add some text counting the number of times we end at 0 and then the number of times we cross 0. Let me restore the original input. So the function animate pointer is the one that's animating the pointer. Do I want to draw the text at this point? I feel like I do, only because this is the best place to know whether I've crossed the 0 or not. So I didn't mean to open this. So I think here we will also write the text. So we draw the pointer and then we draw the scores. And let's do the part 1 score and the part 2 score. Now, how do I want to keep track of state? Do I want to use globals? Do I? I don't know, maybe I do. Just for the sake of simplicity now. Alright, so let's do the following. Let's create a function that draws the scores. So def draw scores. This writes the part 1 and part 2 scores on the screen. And now I need to check the Pygame documentation on how to write on the screen, because I never know these things by heart. Let's see, where is it? Font. So I need to initialize the font module, pygame.font.init. Pygame.font.init. And now I need to grab a font. How do I... okay, that's how I do it. So I render the text. Okay. Every single time I forget how painful it is to write text with Pygame. Alright, so what I'll do is I'll create a font to use with Pygame. I wonder, I don't remember if I can init font before setting the display and then creating a font here that I'll use. Pygame.font. Okay. .font, and now I need the default font, get default font. I'm not going to be picky, just use one that Pygame can give me, get default font, alright. So actually I'm not sure if the order of these things is right, so let me check. Let's see if this runs or if it's going to break. Of course, font module not available, cannot import from partially initialized module. What am I doing wrong? Circular input. That's import. That's kind of weird. How did I get myself into a circular import? Let's move this out. Let's see if the issue is I'm trying to get this stuff too soon. Let's run this again. Nope, still wrong. Brilliant. So what could be the issue here? I'll tell you what. I'll look at code of mine that uses this. Let's do github.com. Where does this live? Now, which of these? So this is the code for a book that I wrote about Pygame. Pygame.font.init. Right, so what's the problem? So I set the display. Maybe the code is too small for you folks to read. Let's do this. So I'm importing Pygame. First I initialize the screen, then I initialize this. Okay, this is slightly different from what I had, but let's see if this runs. So now we uv run dial.py. No, still circular import. Oh no, now the error is slightly different. Font not available. Could it be the locals imports that's messing things up? Nope. Alright, so let's do font module not available. Let's Google this, because I have no idea what's going on. Yeah, okay, so the first result is from Python 2.7.2, which was ages ago. Encountered the same problem. Maybe I'm doing this too early. What code did I have? I had this. This is what I took from a book. Nope, still not working. Huh. Now, what Python version am I running this on? Let's see if I can get this to run with 2.12. uv run dial.py. uv run Python 3.12. 3.14 is still fairly recent, so maybe Pygame has some issues there. Yeah, what do you know? It's working now. Alright, so it was a Python version issue. Okay. So we have a font. Let's say that this needs Python 3.12. Is this the right way? Nope. Does it take a double? Yes, okay. So we have a font. Let's move it up. We have a font. Now we can write text. So to draw the scores, you're going to take the font and render the score. Let's just say that the score is 0 by default. Let's fix it in a bit. So we render the score. We get the surface back, I think. Actually, I can also use this to see what's being done here. Show message and wait. So you render some text. What's the one that's for the anti-alias? Where's the method render? .render. So you want to anti-alias and then the color. So yes, let's anti-alias and the color, let's make it black. So you render the text, then you compute its dimensions, and then you determine where to put it. Okay. I'm actually going to copy this and reuse it. So this is going to be the rendered text. I'm going to paste this here. So this gives me the dimensions of the text. I have the screen width and height, which I already know because I have constants for that. And this would center the text on the screen. I don't want it centered, I want it in the lower left corner. So that's going to be what? This is going to be 0 for the x, and the y is going to be the height minus the text height. This should be it. Now this should put a 0 in the lower left corner of the dial. Let's see, where's the dial? I do not see a dial on the screen. Oh yes, I do, and then it died. Text must be, of course, my bad. The score should be a string. Apologies. Alright. Okay. Now what we need to do is make sure that the 0 is not static, that this actually increases with every time we stop at 0. So let's close this. The score is not always 0. Also, let's add a little bit of padding. Maybe 20 is going to be enough, I'm not sure. Now this should be the part 1 score. Alright, this is where my code starts. Part 1 score starts off as 0. And whenever we are animating, we need to check if the position is 0, because if it is, then part 1 score increments by 1. Part 1 score plus equals 1. And that should update the drawing. Now to test this sooner, let's just do a bunch of fake rotations. So 10, and then we undo by 10, and this should give us a score of 2 fairly quickly. So we start off as 0. We're going left 50 turns, so this should give me a 1, and now we go 10 and then back, and then we get a 2. Alright, so the score for part 1 is being accounted for, which is great. Let's check the time. Oh wait, we don't have any more time for today. Alright, so it's 6 p.m. UTC, and I have to call it a day here because I have another session to go to, a private session. But this is a good place to stop because we made some nice progress. So yeah, we'll call it a day here. Thank you so much for dropping by and for watching. Today I'll be back at 5 p.m. UTC again to solve day 3 of Advent of Code, and then depending on how it goes, I might come back to this to finish it, since we're fairly close. Thank you so much for watching, everyone, and talk to you later. Bye.